Hash functions are everywhere in the digital world. From securing passwords to enabling blockchain technology, they are the unsung heroes of cryptography and data integrity. But what exactly are hash functions? Let's dive in. A hash function is a mathematical algorithm that transforms input data, like a message or file, into a fixed-size string, often a hexadecimal number. Key characteristics of hash functions include 1. Determinism. The same input always results in the same output. 2. Fixed output length. Regardless of input size, the output remains consistent. 3. Collision resistance. Ideally, no two inputs produce the same output. 4. Efficiency. They're designed for fast computation. Hash functions are fundamental for ensuring data security and integrity. To understand why hash functions are so vital, let's explore their core properties. Pre-image resistance. It's nearly impossible to deduce the input from the hash value. Avalanche effect. A minor change in the input creates a vastly different hash. For example, hello and hello produce entirely distinct outputs. Collision resistance. Avoiding two different inputs resulting in the same hash is essential for security. These features make hash functions indispensable for digital cryptography. Some well-known hash functions include MD5, which is quick but insecure, making it unsuitable for modern applications. Then there's SHA-1, slightly more secure than MD5 but now deprecated due to collision vulnerabilities. SHA-256 is a robust, widely used standard in applications like blockchain and TLS certificates. And finally, SHA-3, the latest algorithm with enhanced security features. Each serves specific use cases, but only SHA-256 and SHA-3 are recommended for high security needs today. Imagine a hash function as a digital fingerprint for data. It processes the input, breaking it into fixed-size blocks, and applies mathematical operations to generate a unique fixed-length hash. For example, let's take the input, hello. The SHA-256 algorithm executes rounds of bitwise transformations. The output is a unique 256-bit hash string. This process ensures that even minor input variations result in unique, unguessable outputs. A collision occurs when two inputs produce the same hash, which can undermine security. Older algorithms like MD5 are particularly vulnerable. Modern hash functions such as SHA-256 and SHA-3 use complex structures to resist such attacks, making collisions computationally infeasible. When users create passwords, the system doesn't store the actual password. Instead, it stores a cryptographically hashed version of it. This makes direct password theft from a database breach much harder. But attackers have tools like rainbow tables, pre-computed lists of hashes to crack passwords. How do we fight this? With salting. What is salting? A salt is a random string added to the password before hashing. For example, password 123, salt random salt value. Final input to the hash, password 123 random salt value. This extra step ensures that 1. Identical passwords produce unique hashes. If two users choose the same password, their salted hashes will still be different. 2. Rainbow table attacks are thwarted. Since each password has a unique salt, attackers can't use pre-computed hashes to guess the password. By combining salting with strong hash functions like SHA-256 or bcrypt, modern systems provide robust protection for user credentials. In blockchain technology, hash functions ensure data integrity and security. Each block contains the hash of the previous block, creating an immutable chain. Hash functions also power the proof-of-work process, where miners solve complex puzzles to validate transactions. Input transaction data. Output. A hash that meets the mining criteria, like a specific number of leading zeros. By securing each block with hashes, blockchain systems achieve data immutability and transparency. Hash functions are the backbone of modern cybersecurity, enabling everything from secure communications to decentralized finance. As digital threats evolve, these robust algorithms remain critical for safeguarding our data and systems. If you found this video insightful, don't forget to click the subscribe button and hit the notification bell so you never miss out on more in-depth explorations of technology and cybersecurity. Share this video with friends who'd love to learn, and let us know in the comments what topics you'd like us to cover next. Thanks for watching.